Okay, now let's go to the blocks, randomized block design. Okay, sometimes you may have this information, but you may have divided by there may be some other element that might cause the variation. Okay, let me open the controller. Where is the controller? Air traffic. Okay, let me open that that for you. We have the controller 1, 2, 3, 4, 5 and the system A, B, and C, and we want to know if systems A, B, and C are different. But we know that there might be some factor, some other element that might affect the variance in these three groups. Okay, by including this block over here, we wipe out the effect of the controller, and we are going to really check if these three systems are different. Okay, the same thing may happen, for example, when you have a sales representative and you want to measure the number of calls they make. Okay, and you have all your data. However, you may consider the day of the week for each one of those. So you include the day of the week as a block, because you don't want the day of the week affect your overall interpretation of the differences between your three sales representatives. That is why you include the block. Okay, let's do this using ANOVA. So it's exactly the same, but you have to include this other element that might influence your variance, in your total variance. So again, you go to data analysis, and instead of going a single factor, you have to do a two-factor without replication. Why? Because you have only one sample for each one of these controllers or of these blocks. Okay, in other statistical software, this is called the two-way ANOVA. Okay, let's go to this one without replication, hit OK, and it's going to give you the input range, and the input range is all this. They have labels both on the top and on this one. Okay, this is the label for the controller, this is the label for the system. You're going to get alpha 0.05, and you are going to set your output range probably here. Hit OK, and it's very, very similar to the table, but now it has three rows in here instead of the within and between elements. You are going to have the rows, and these rows are the blocks, the columns, that these columns are the treatments. Okay, these are the columns, the system A, B, and C. This is the treatment that you really want to consider. This is the row and the error. So if you, the purpose of this is to wipe out the effect of the rows in here, of the variation because of the rows. So you need to find out first if the blocks really affect your dependent variable, the variation on your dependent variables and the dependent variable. So, and again, this is a pretty easy table for making the interpretation. If you add 30, 21, and 19, you are going to have 70. This is the total. This is the sum of a square because of the blocks. This is the sum of a square because of the treatments, and this is the sum of a square because of the error. Okay, in the rows, you are going to have how many degrees of freedom? The number of rows or the number of blocks minus 1. This is the degrees of freedom for the blocks. In the columns, you are going to have what? These three, okay, minus 1 is 2. and the degrees of freedom for the error is 10. So if you add these elements, it's going to be 70. When you to calculate the mean square because of the block, it's going to be 30 divided by 5 is 6. The mean of a square because of the treatment is 21 divided by 2 is 10.5, and 19 divided by 10 is 1.9. And this f value is the mean square because of the block divided by the mean square of the error. Okay, 6 divided by 1.9 is 3.1. This one over here is this 10.5 divided by the mean square of the error, 1.9, and this is 5.5. These are the critical values, and these are the p-values. Now, over here, we almost have, because we have 0.05, almost have that the controller are a key element in the variation of the of your dependent variable of your of this. Okay, so for the treatment, you do have a real significant difference in the treatment. So you reject the null hypothesis and you say that the treatments are different in this case. Now, when do you block, or when do you do not use blocks? When you think that there is something in your data that might affect the overall variance, then you block it. If there is a significant value over here from the block, then whatever you find in your treatment, you get it. So in this case, almost find a difference. So let's say that, yeah, there might be some statistical differences in the way the blocks respond. So we do have that the means on each systems are not equal. So we ended up with that. So when to block or when not to block? Okay, first you need to consider if there is some elements that might affect your overall variance. Then you run your ANOVA table with blocks, okay, with a random block. And if there are differences, then you immediately make the conclusion based on this table. If there are no differences in the block, what you have to do is to run the ANOVA, the simple ANOVA, and see if there are differences in the treatments or in these three systems. Basically, that's it. That's all that it gives you. And we found, because of this 0.02 is less than 0.05, we reject the null hypothesis and we conclude that not all the means are equal.